Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about Euler's theorem. So in order to understand this Euler's theorem, we are going to use multiple concepts which we already discussed in our previous classes, like properties of GCD, congruence properties, and the theorem which we discussed in our last class. All these things we are going to use. Hoping that you already have that basic knowledge, the explanation is provided here. So what is meant by Euler's theorem? What we have to show, let's try to understand. If GCD of A comma M equal to 1, you take any two numbers A comma M and the GCD value is equal to 1, then A power phi M congruent to 1 mod M. This is what we need to show. Here phi of M means Euler's phi function. Let's assume that A is equal to 21 and M is equal to 20. GCD of 21 comma 20 equal to 1. And what is meant by Euler's phi function? Phi of 20 equal to, what is the phi of 20 value? 8 values are there in phi of 20. What is meant by that Euler's phi function? The values that are less than 20 and their GCD value is equal to 1 with respect to 20. Means 1, 3, 7, 9, 11, 13, 19. How many values are there? 8 values are there. That is what Euler's pi function is going to provide. So A power 8 congruent to 1 mod 20. This is what we need to show. In order to show this, see here, what is reduced residue modulo with respect to 20? 1, 3, 7, 9, 11, 13, 19. This is what reduced residue modulo means. We name it as R1, R2, so on, R phi of M. How many values are there in reduced residue modulo? Same as Euler's phi value. 8 values will be there. Be a reduced residue modulo. If you assume that this is the reduced residue modulo of 20 or M, then in our last class we clearly discussed that AR1, because A is the GCD of A with respect to M is 1. GCD of A comma M is equal to 1. So from this, if this is accepted, then AR1 comma AR2 so on AR phi is also a reduced residue modulo. This theorem we already showed in our last class. And we are going to revise some concepts here. Based on the concepts, we move on to the Euler's proof. All these concepts are discussed in our previous classes, but we want to revise these ones for better understanding of Euler's theorem. So this is the concept which we already discussed in our last classes. If R1, R2, so on, R phi is a reduced residue modulo, then this is also a reduced residue modulo. The next concept you need to understand, if A congruent to B mod M and C congruent to D mod M, see one of the property, then AC congruent to BD mod M, means we can multiply A with respect to C and we can multiply B with D. AC congruent to BD mod M. So multiply, you are going to get the same modulus value. So similarly, and one of the concept, this concept we are going to use here, R1 congruent to AR1 mod M. See what's this? R1 means reduce one of the value in reduced residue modulo. Then definitely it may be AR1, it may be AR2, one of this is going to be same as R1. Which one we don't know. Here we are assuming that AR1 is also same as R1. So R1 congruent to AR1 mod M, R2 congruent to, similarly one of this AR phi value will be equal to R2, but we are assuming here AR2 modulus M both are same. If this happens, then we can write it as R1 R2 congruent to AR1 AR2 modulus M. This can be extended to all the values of R1 and AR1 because it is multiplication. You take this as one number, AR3 as second one, multiply. This concept, this property explained in our previous classes. This property we are using here. The same property we are extended. So from this property, we are going to extend to all the values in R1 and AR1. From that, we are going to derive Euler's theorem. So multiplication means here we can use pi value. So pi j equal to 1 to phi of m. Arj means we are multiplying all these values. It is congruent to, yes, pi j is equal to 1 to phi of m. Rj mod m, because both are giving the same residue values. Multiplying it, it is going to give the same, because R1 R2 multiplied, AR1 R2 multiplied. It is going to give the same from this theorem, from this property of congruence. So this is we got from here. So now from this, remove a outside. How many a's will be there? Ri, Rj, Rj1, Rj2, Rj3, Rj4, so on up to Rj phi of m. So take a's outside. How many a's will be there? A power phi m. 8 a's removed. Here from this example, phi of 20 means 8. A power 8. So if you remove a outside, pi j is equal to 1 to phi of m, Rj congruent to pi j is equal to 1 to phi of m, Rj mod m. Can we cancel this? Pi j is equal to 1 to phi of m, Rj, j is equal to 1 to m phi of m, Rj. Can we cancel this? Yes, we can cancel this from the congruence property in our previous classes, because when we are able to cancel, if GCD of Rj comma m is equal to 1, then only we can get cancelled both sides. Yes, GCD of Rj comma m is equal to 1, because Rj value is a reduced residue modulo value. Means GCD of Rj comma m is equal to 1. But here multiplication of all Rj's, yes, it is also going to provide GCD value 1. Why? Because from the property of GCD, if GCD of A comma m is equal to 1 and GCD of B comma m is equal to 1, then GCD of AB comma m is equal to 1, because all Rj's GCD's values are same, 1. Multiplying them, you are going to get GCD value 1. So that's why you can cancel both sides. If you cancel this, A power phi m equal to 1 mod m. This is what we need to show. Hope you understand Euler's theorem, the definition, the derivation of Euler's theorem. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.